Greetings, grade 7, and welcome to another wonderful day of learning. I'm Mrs. Hall, and I look forward to teaching you your lesson today. Let's get started. Today's lesson is on mixtures and pure substances, and we are going to make sure that by the end of this lesson, we have covered the following objectives. We're going to look at the revision of mixtures from grade 6. I always like to go back just a little bit backwards so that you've got the building blocks to move you forward. It's very important that we recap and then we are able to move forward with a solid understanding of previous knowledge. We're going to look at homogeneous and heterogeneous mixtures. We're going to look at simple ways to separate mixtures and how they benefit us in everyday life. We're going to look at pure substances such as elements and compounds, which are going to start getting us ready for the chemistry component moving into high school. And then I'm going to end off with a little quiz just to make sure you've been paying attention and have remained focused for the lesson. Let's get started. So, mixtures. Mixtures can have visible parts we can see, like sand and water, oil and vinegar, iron and sand. Those are all distinctive components of a mixture where we can see the sand and we can see the water. Mixtures can also have no visible parts, and they are called solutions. Like, for example, salt and water may form a saltwater solution, or that famous one that we all love to drink, Kool-Aid or ORS, things like that. Now, by no visible parts and forming a solution, we know that, for example, salt and water, salt can dissolve in the water and we can't see the different components. Right? We're not able to actually see the salt and the water separately. It forms one solution. Now, a mixture is a substance made by combining two or more different materials in such a way that no chemical reaction occurs. A mixture can usually be separated back into its original components. Exactly like this bowl of nuts here, we can separate our cashews from our almonds from our peanuts, whatever mixture of nuts we have in there, we are able to separate them. A heterogeneous mixture is a mixture where you can distinguish all the components. Right? Is this coming back to you from grade 6? Heterogeneous, scientific term. I'm able to separate the banana from the kiwi, from the pawpaw, from the watermelon. I'm able to separate the olives from the tomato, from the lettuce. And this morning, while you were eating your breakfast, you would have been able to separate your cornflakes from your milk. That forms a heterogeneous mixture. Another kind of mixture is an homogeneous mixture, whereby in this kind of mixture, you can't distinguish all the components. For example, my cup of coffee this morning, and maybe you're drinking coffee now, grade 7, maybe keeps you awake during this time of intense online learning. If you put coffee in your cup and then you put in the hot water, the coffee and the sugar as well dissolves into the hot water, and then you put your milk in and that also mixes in with your coffee, and you are unable to tell the different components apart. It forms an homogeneous mixture. One of my favorites, strawberry milkshake, ice cream, strawberries, and milk. But if I wanted to separate this milkshake, I wouldn't be able to tell the different components of it apart. A few other examples from everyday life: chocolate, cold tomato soup, and you all know orange juice. Now, processes to separate mixtures, you learnt about a lot of these in grade 6. So when some materials are mixed together, it is possible to separate the mixture and get the original materials back again. There are several different ways of separating mixtures. The best process to use depends on the type of mixture you are separating. Now, when I speak about the type of mixture you are separating, for example, you might be separating a solid from a liquid, for example, or a solid from a solid. So today we're going to delve a little bit deeper into evaporation and condensation in everyday life. We're going to look at magnetism. Most of you know it, but it's part of our grade 7 curriculum, so we'll go through it quickly. And then we're going to look at filtering in a lot more detail and how we use it in everyday life. And then in grade 6, you would have used these methods: sieving, decanting, and hand sorting. Those are physical methods of separation you should all already know. Right, how would you separate a mixture of sand and water? Now, sand here is our solid and our water is our liquid. In scientific terms, we call the water the solvent and we call the sand the solute. And this has made up a mixture. However, the sand, the solute, is insoluble in the solvent. It's not able to dissolve, and that is why we can still see the two different components. But how would we separate them? We would pour the mixture through a filter. The filter will go through the filter paper, leaving the sand behind. And you would have done this little experiment in class in grade 6. Okay, but now we delve a little bit more deeper in grade 7. Let's look at it in everyday life. So when we're making cream cheese, so we're baking a delicious cream cheese cake, one of my favorites again. Oh, I seem to have a lot of favorites that are all dairy related. Don't know if that's a good thing. Anyway, when making cream cheese, the sour milk is placed in a muslin bag, and the liquid, which is called the whey, is filtered out, leaving the curd behind, which is actually the cream cheese. And there you have an example of a muslin bag, okay, and it's used as a filtration system. Now, obviously, if you are buying cream cheese from Pick n Pay or wherever your mom buys it from, it's gone through a factory process of filtration. So it's a lot more in-depth than just using your little muslin bag that you have at home. But that's how you get delicious cream cheese. Now, take a look at this picture. You've all walked past one or driven past one or played near one. This is a wetland. And how do wetlands use filtration in everyday life? So, the water coming into the wetland carries suspended particles of sand, and that flows into the wetland where there are plants with lots and lots of roots growing under the water that you can't actually see. The water is slowed down because of the roots, and the sand particles that are flowing in get stuck in the roots as the water continues to flow through. So it's already starting to filter, grade 7s. Wetlands act as filters, removing the sand particles, and so reduces soil erosion. They also slow down the movement of water, so there's way less flooding. And that's why it's so important that we look after our wetlands and we have conservation projects to look after our wetlands. So wetlands clean water through the process of filtration. Hope you've learned something new there, grade 7. How would you separate a mixture of iron and sand? So here we have our iron filings and our sand, and in class we had a lot of fun separating this. We did all kinds of different things. We would put it into water, stir it up, try and separate it with the water in a beaker. We made fancy patterns with magnets, north and south poles. A fun lesson, and I'm pretty sure your teachers will go back through this with you when you get back to class. You would use a magnet to separate the iron from the sand. There you go. So quite simple, taking your magnet, sticking it into your little glass plate over here, and taking the iron filings out of the sand. How would you separate a mixture of salt and water? Now remember, this has formed a solution. We cannot see the salt, that it has dissolved into the water. So the solute has dissolved into the solvent, and formed a solution. And how would we separate this now? Okay, I've already given you the hint. The salt and the water form a solution. The correct way would be to heat the water until the water evaporates and only the salt will remain. So in class, you would have had your little Bunsen burner, your little flame, you would have had your solvent mixed up with your solute in a glass beaker, and then you would have heated the beaker using your tripod stand over here, and the water would have evaporated, leaving only the salt behind. How is this used in everyday life? Evaporation. In very hot areas, especially near oceans, people can spread seawater into shallow pans. And here you see the shallow pans over here. The sun's energy evaporates the water, leaving only the salt behind. So using nature like this not only creates jobs, but it also gives us sea salt. So the next time you are grinding that sea salt onto your food or your delicious chips, think about where that salt came from, grade 7s. So let's take a look at this slide over here. Obviously, matter, different states, solid, liquid, gas, and we are now looking at mixtures. And today we looked at mixtures, we looked at heterogeneous, we looked at homogeneous mixtures, and we looked at physical methods of separating these mixtures. Now we're moving on to pure substances. And what makes up a pure substance? Pure substances are made up of elements and compounds. So this is where you need to sit up and really start paying attention. At first, like I tell my grade 7s, you get a little bit worried and you get a bit concerned. Do I understand? I don't know what she's talking about. But the more we go through it and the more we keep going back, the easier it becomes. Right, so now we're looking at pure substances as opposed to a mixture. Now, pure substances are defined as substances that are made up of only one type of atom or molecule. Don't get confused about an atom or molecule yet. We will go deeper. The purity of a substance is the measure of the extent to which a given substance is pure. So, let's take a closer look. What is a pure substance? Right. A pure substance is, oh, that writing's quite small for me, has constant composition and distinct chemical properties. Let's take a closer look. The law of constant composition says that in any particular chemical compound, all samples of that compound will be made up of the same elements in the same proportion or ratio. Stay with me. Don't go away. It makes a lot of sense the further we delve. Okay, so this would be examples of pure substances. Now, pure substances can be simple substances, or they can also be a compound. A simple substance is made up of just one type of atom. A piece of gold is made up of only gold atoms. So this would be a pure substance. This block of gold is 100% pure. Look at the chemical composition. It is pure, only one kind of atom. Let that sink in. Pure, one kind of atom. While compounds now are made up of more than one type of atom, and they are joined together. And the example I've used here is pure water. So look at this hydrogen molecule. It consists of 2 hydrogen atoms and 1 oxygen molecule. And here you can see it quite clearly. 2 hydrogens, 1 oxygen. Now this is a compound. It is made up of more than one type of atom. Gold was pure, made up of only one type of atom. Compound is made up of more than one type of atom. Example, water, H2O. Are you understanding the difference now between a pure substance and a compound? Elements, also a new word for you. An element is a material that is made up of atoms of only one kind. So this would be a pure substance. And the correct scientific terminology for a pure substance of atoms made up of only one kind is an element. And grade 7s, we learn about the periodic table further on, and we learn about all the different elements of the periodic table. Good news for you, in grade 7, you only need to know the first 20 elements. It's a good, fun lesson, and I love teaching it. Now, let's go back. A compound is a material that is made up of two or more kinds of atoms, and they are chemically bonded together. Is this making sense to you now? I hope so. Okay, so just by going back and repeating, what is an element? Made up of one kind of atom. A compound made up of two or more kinds of atoms. And these atoms are chemically bonded together. The compound consists of atoms, but there are more than one kind. Here we go again. An example. The different atoms are combined in little clusters, and each little cluster is exactly the same. So here we go. Exactly the same compounds combined. So let's take a closer look again. Let's break it down for you. Matter. In matter, we have pure substances and we have mixtures. Pure substances are made up of elements, atoms of only one kind, as well as compounds, where there are two or more atoms combined together to make up a compound, but they are both pure substances. Mixtures are made up of homogeneous mixtures or heterogeneous mixtures. Is this all making sense now? Is it all coming together? I really hope so. Let's have a little quiz. You can either grab a piece of paper or just follow with me. And I don't mind if you shout out because I can't hear you anyway. Question number 1. What is the name of two or more elements being chemically joined? So two or more elements being chemically joined. Look at your options. Is it an element? Is it a compound? Is it a mixture? Is it an atom? But remember, they're being chemically joined, two or more elements. It would be a compound. Hope you got that right, grade 7s. Question number 2. What is a substance made from only one type of atom called? Remember, it's a pure substance, one type of atom. Which would it be? Take a look. A, B, C, D. Shout it out. I can't hear you anyway. It is an element. Number 3. What is the name of a material that has two or more substances together, but they're not chemically joined? So, two or more substances together, but not chemically joined. Is it a compound? Is it an element? Is it a molecule? Or is it a mixture? It's a mixture. Gold is it a mixture? Is it an element? Is it a compound? Is it an atom? It is an element. Pure substance. A substance in which a solute dissolves is called a, this is coming back from grade 6. The substance in which a solute dissolves is called a, you should see it straight away, it's a solvent. A solute and a solvent added together make up a, do they make up a compound? Do they make up a liquid? Do they make up a solution? Do they make up a mixture? A solute and a solvent added together make up a solution. Which picture shows a pure compound? Now, a compound is two or more atoms that are chemically joined. Right, take a good look at these pictures now, because this is where it gets a little bit more difficult. Which picture shows a pure compound? Two or more atoms joined together. There we go. Question 9. Which picture shows a mixture of elements? Okay, so elements, pure substances made up of only one kind of atom, joined together, right? But it's pure and it is a mixture and they can be separated. Correct. Number B. It's a mixture of different elements. Grade 7. That's it. I hope you enjoyed this lesson today. I hope you learned something new. Please download the worksheets that we have prepared for you and go and do a little bit of revision today. I hope your PowerPoint presentation is coming along nicely, and I'm sure your teachers are looking forward to watching them. Take care. Have a great afternoon.